Hello everyone, welcome to the ITLS Academy. Today we are going to discuss another topic in the series of food processing, and the topic that we are going to discuss is about the sterilization of the food product. Simply here, the term sterilization means that we have to destroy the all type of microorganism present in a food product. In pasteurization, what we do, we only targeted the pathogenic microorganism, but when we do a sterilization, it kill all type of the microorganism. Either it is the spore forming, pathogenic, spoilage, any microorganisms cannot be survive at that um, time when we apply the high heat. Okay, basically in sterilization, what we do, we apply a high amount of heat. Okay, that is known as a sterilization. Unit operation, like food are heated sufficiently at a high temperature. Okay, that I already told you. Here again, this when we do a sterilization, we have two combination. The one is your temperature and another one is your time. Here we apply a high temperature, and even we hold that high temperature at a longer period of time, which destroy the microbial and enzyme activity of the food product. And when we do a sterilization, the sterile product have a shelf life more than 6 a month, even at a normal room temperature. Okay, now severe heat treatment during the older process in container sterilization. Okay, so this heat sterilization, or what it is, a severe heat treatment, means that we use a high amount of the heat, and this process is very older. Like we do a in container sterilization. In case of the canning, in canning, what we do, we fill the food product and seal it, then after that we sterile it. Okay, it produces a sustainable changes in nutritional and sensory quality of the food product. Although this heat sterilization can affect the nutritional and sensory quality of the food product, more recent development introduce advanced technology like omic eating, which reduces the damage of the nutrient and sensory component. Okay, omic heating is also the part of the heat sterilization, but when we do a omic heating, it reduces the nutrient loss and sensory component. So there are two main procedure of the sterilization. The first one is your in container heat sterilization, and the second one is your UHT process. So the first one is your in container sterilization. In container sterilization, the length of time is required to sterile a food, that is influenced by. Okay, so when we do a sterilization in container, so here we required a holding time, that is known as the length of time, means that we have to hold a temperature at particular, sorry, we have to hold a temperature for a particular period of time. That time is known as the length of time. Okay, and that length of time is depend upon these several factors, like your heat resistance of microorganisms or enzyme, means that the food product contain which type of the microorganism and their heat resistant capacity. And the next is your rate of penetration into the food product, even the pH of the food product, the container size, and physical state of the food product. So these are the factors which is responsible for the length time required for the sterilization of the food product. Heat resistant of microorganism. The first one is your heat resistant. So the heat resistant spore forming microorganism, that is your Clostridium botulinum. So these Clostridium botulinum is a bacteria which are heat resistant, and it can be spore forming microorganism. So this come under the category of the pathogenic microorganism, and even it is a most dangerous pathogen present into the food product. Okay, under the anaerobic condition inside the sealed container, it can be grow under the mm, sealed condition, even the that anaerobic condition. It also produces a exotoxin that is called a botulin, and this botulin is very toxin, powerful toxin. Okay, minimum requirement for heat sterilization, like in low acidic food, pH is less than, pH is uh, more than 4.5, it can destruct the Clostridium botulinum is a minimum requirement of heat sterilization. If we talk about the normally, then the destruction of that Clostridium botulinum in case of low acidic food only ensure that destruction all other heat resistant spoilage microorganism. If this microorganism is destroyed, then it means that the other type of the spoilage microorganisms will also destroy, which are present into the low acidic food. Then if we talk about the acidic food, in which the pH ranges between the 4.5 to 3.7, like heat, yeast and fungi, or even a heat resistant enzymes. They are used to establish the minimum requirement of that processing time and temperature for the sterilization of the food product. Next is your in more acidic food, like in which the pH is less than 3.7. In that case, there is the destruction of the enzyme, and minimum requirement of processing time and temperature is required. Okay, sometime it can also refer as a pasteurization, because here we only use a minimum heat for the destruction of the microorganism. Maximum heat is required in case of that, in which the pH is more than 4.5, but it is low, it come under the category of the low acidic food. But when we have a acidic food, whose pH is at the range of 4.5 to 3.7, then in that case, most of the microorganism will be destroyed and we required a minimum processing time. But when we have to destruct the more acidic food, to even the minimum processing time is required, and along with it the temperature is also required, and we can sometimes we can refer as a pasteurization. Heat resistant of some spore forming bacteria used as a basis for heat sterilization of the low acidic food. The first column represent the microorganism, then second is Z value, then third is D121 value and typical food. Now if we have a thermophilic microorganism which can be survive at the range temperature range between 35 to 55 degrees Celsius. So the first example of thermophilic that microorganism is your Bacillus stereothermophilus, whose Z value is 9 to 10 and D121 value is 3.40 to 4.0, and typical foods is vegetables and milk. The next is your Clostridium thermocirculolysiticum, whose Z value is 7.2 to 10, D121 value is 3 to 4, and the typical food is vegetables. Then mesophilic, whose temperature ranges between 10 to 40 degrees Celsius. Okay, the first example is your Clostridium sporogenus. The temperature range, Z value is 8.8 to 11.1. D12 is 0.7 to 1.5, and meat is a product. The next is your Bacillus subtilis. Z value is 4.1 to 7.2, D12 is 0.3 to 0.76, and the product is milk product. Next is your Clostridium botulinum toxin A and B. So Z value is 5.5, D12 is 0.1 to 0.3, and typical food is low acid food. Next is your Bacillus coagulans. So, Z value is 6.6 to 9, and D12 is 0.01 to 0.07, and the product is milk. Bacillus cereus, Z value 36, D12 is 3.8, and product is milk. Then the next category is your psychrophilic, which can be grow at a temperature range between minus 5 to 1.5 degrees Celsius. Okay, though Clostridium botulinum toxin E. Z value 10, D12 is 3.0, 60 degrees Celsius, and food is low acidic food. Thermal destruction of the microorganism. Heat is a leather to the microorganism, but each species has own particular heat tolerance. Okay, we all know that this heat is very dangerous for the microorganism. It can destroy the microorganism, but there are certain species which are heat tolerance. Okay, so the process which depend both on the temperature of the exposure and the time required to this temperature to destruction. Okay, when we apply the heat to the food product, and the destruction of the microorganism is depend upon the two things. The first one is your temperature exposure and the time required, so that temperature can penetrate inside the microorganism and destroy it. Thermal destruction of microorganisms simply explained by their D value. D value differ for different microbial species. If a D value is higher, then it indicates that greater heat resistance. And 12 D value means that Clostridium botulinum are destruction. Decimal reduction time or D value. So D value is simply means that the decimal reduction time, and it is means that the time required at the particular temperature and even at up under that specified condition, so that it can reduces the microbial population by 1 decimal, means that the total time which is required at a particular temperature and even under that specific condition, so that it can reduce the microbial population 1 decimal. Here the decimal reduction time depend upon the temperature, type of microorganism, composition of the medium which are present into the microorganism. For example, a D value at 72 degrees Celsius for 1 minute means that processing time, like each minute of processing at 72 degrees Celsius, the bacteria population of the target microorganism will be reduces by that 90%. That means that the value. Now come to the next slide. Specific temperature at 120 degrees Celsius under a specified condition. Here the D value is in 14 minutes, like 40 to 20 seconds, and would be represented by the process at 120 degrees Celsius. And this graph is in between the number of living microorganism and the time required. You can see that when like when a time is increases, then the number of the living bacteria which are present into the food product is decreases. Okay, and here a specific temperature is apply, that is around 120 degree Celsius. Z value is the increase in temperature required to reduce the decimal reduction time by 1 decimal. Here Z value means that when we increase the temperature which is required, so that it reduces the decimal reduction time by 1 decimal, and it is a measurement of the change in death rate with the change in temperature. That is known as a Z value. The 12D process means that we have a canned product, and these canned products are very susceptible that the spores forming microorganism, that is your Clostridium botulinum, can grow on that canned food product. Okay, and this Clostridium botulinum are responsible for the botulism, and these bacteria spores can survive many heat treatment process. If we talk about the modern food production, then the canned food are subjected to a time temperature process which reduces the survival chance of the most heat resistant bacteria, that is your Clostridium botulinum spore, by 12 log or 12 DE at 121.1 degrees Celsius temperature. Here the 12D means that the 12 log cycle reduction of the microorganisms. That means that the 12D value simply means that 12 log cycle reduction of that microorganism. This is about the 12D process. For example, if there were a 10,000 spores of species of spore present in a can for, and we have a 12D process. Then initially this 10,000 spores have 10 to the power 4 spores. Then it reduces to a theoretically 10 to the power minus 8 living spore per can, which reads that 10 to the power minus 4 divided by 10 to the power minus 12, that is 10 to the power minus 8. So here it is the graph between the number of the microorganisms per unit and between that sterilization time. This graph is sterilization temperature, that is your D value at 121 degrees Celsius between that number of microorganism per unit time. When a temperature is increases, obviously the microorganisms number will decreases. Examples of how to use D and Z value in heat calculation. We have a raw milk in the processing plant, and in that raw milk there is a bacterial load which is around 4 into 10 to the power 5 per ml. When we process this milk at 72 degrees Celsius for 210 seconds, okay, what we have to do, we subject the milk at a heating condition, and we apply the heat around 72 degrees Celsius for around 210 seconds. Then the average D value at 65 degrees Celsius for the mixed population is around 7 minutes, and Z value is 7 degrees Celsius. Now, how many microorganisms will be left after the pasteurization? So this is a question for you. You have to write down in the comment box. The question will be clear. You have to write down your answer in a comment section. Now, type of microorganism important in retorted food. Like the first column is for the type of the microorganism, then their species, then their description. Then the first is your thermophilic spore formers. That is your flat source, Bacillus stratothermophilus, heat, high heat resistant product acid, don't produce gas, found in sugar, salt, and spices. Next is your thermophilic anaerobes, Clostridium thermosaccharolyticum. Description: high heat resistant product acid and gas. Sulfide type, Dissect Photmoculum negrifications, high heat resistant, produce H2S. Next category is your mesophilous spore former. The process should be designed to kill this microorganism, that is your Clostridium sporogenus and Clostridium botulinum. They produces the gas like CO2 and also produces sometimes hydrogen, moderate the heat resistant. Bacillus species, that is your Bacillus polymyxa and Bacillus marcanans, etc. They are moderate to low heat resistant and some may grow at a high acidic foods. Rate of heat penetration, it depends upon the different factors which influences that the rate of the penetration, like type of the products, size of the container, agitation of the container, temperature of the retort, and type of the container. The first one is your type of the food product. If we have a liquid food product, like suppose that tea is present in a brine, then a convection heat transfer faster than in case of the solid food product by conduction. Okay, so if in case of the liquid food, if we apply a convection heat transfer, then it can be faster as compared to the solid food product where the heat are transferred by the conduction method. The next is your size of container. If the size of container is high, means large, then the penetration power is slow. And if the size of the container is small, then the penetration power is high. Agitation of the container, like control the cold point effect. If we increase the rate of heat penetration in viscous or semi-solid food, like suppose that the rate of heat penetration increases when we have a viscous or semi-solid food. Higher temperature difference between the food and the heating medium cause the faster heat penetration. And heat penetration is faster through the metal than a glass. If a container is made up of the metal, then in that case, the heat transfer is heat penetration is fast as compared to the container which are made up of the glass. So this is a graph between the heat penetration into the can containing the heating food product, like retort temperature, temperature at the slowest heat point. Why is this important? Like botulism poisoning, because it is the source of trouble. Low acidic food that were improperly canned. Suppose that we have a food product and that food product have a low acidic food, and now that low acidic food cannot can in a proper way. That's why this botulism poisoning occur. Now trouble sign like clear liquid turn into the milky, crack the jar, looser or dented lid, swelling or dented can, and off flavor. Okay. Prevention, examine all the canned food product before the cooking. When we have to cook the canned food product, okay, we have to examine first with very carefully. Cook and reheat the food thoroughly. Keep cooked food hot above 140 degrees Celsius or cold food below 40 degrees Celsius. Symptom after eating like double vision, droppy eyelids, trouble speaking, swelling or breathing. Untreated botulism can be fatal. Sterilization process and equipment. The sterilization process in the canned food can be subdivided into the three category: phase 1, phase 2, and phase 3. Phase 1 is your heating phase. In heating phase, the product temperature is increased from ambient to the required sterilization temperature. What we have to do, we have a product temperature. Now what we have to do, that product temperature are present at a normal room temperature. We have to increase the product temperature from the room temperature to the sterilization temperature. Then we have to hold that temperature, and that phase is known as a holding temperature. Okay, and the temperature should be hold for a defined time. Okay, so there is a different food product for them, there is a different temperature, and there is different holding time. Then after that we have to go to the third phase, that is your cooling phase, in which the temperature in the can is decreased by introduction of the cold water. Batch or continuous type of autoclave or batch retort. Batch retort means they are vertically or horizontal. If the horizontal batch, then it is easier to load and unload and have a facility for agitating, but require more floor space. Okay, if that horizontal autoclave or retort we have, then we have to require a more floor space. Continuous retort, they are permit to close control over the processing condition, and it produce a uniform product, and product are gradual changes in pressure inside the cane, less strain, and can seem compared with that batch equipment. Main disadvantage that high in process stock loss if a breakdown is occur, and there is a problem with that metal corrosion and contamination by the thermophilic bacteria. There is a chances of the contamination which can be occur by the thermophilic bacteria due to inadequate preventing measure. So these are the continuous hydrostatic sterilizer. Ultra high temperature or aseptic processing. Higher processing temperature for a shorter period of time. When a temperature is higher, then obviously the time should be shorter. Otherwise, it totally damage the nutritive quality of the food product. Here in UHT method, we use around 132 degrees Celsius only for a 2 second into the pre-sterile container in a sterile atmosphere. Then what we have to do, we pack the food product into the um, pre-sterile condition, and we have to pack it in a sterile atmosphere, means that we have to eliminate the microorganism in all step, like liquid foods, that is your milk, fruit juices, and concentrate creams, yogurt, wine, salad dressing, egg, ice cream, and mix. And we have a food with a small distinct particle like your cottage cheese, baby foods, tomato product, fruits and vegetables, soups, rice, dessert, and high quality of UHT food, like especially chilled and frozen food product, and the shelf life of the product that we that sterile by that UHT method have around 6 months. And for the storage of that type of the food product, we does not require any refrigerated condition, means that we can store it at even the normal room temperature, and their shelf life is at least 6 months. UHT processing characteristic, like operation above the 132 degrees Celsius, heat transfer exposure for relatively small volume of the product to a large surface area product. It maintains the turbulence in the product when it passes over the heating surface. Okay. When we do a UHT method, then it prevents the turbulence. Use of pumps so that it give a constant delivery of the product in case of heat exchanger. Constant cleaning of the heating surface so that it can maintain the high rate of the heat transfer. It also reduces the burning of the product. UHT equipment are classified into the direct system, indirect system, or other system. Indirect system, directly steam is injected to the food product. Indirect system, we use a plate heat exchanger, tubular heat exchanger. Okay, microwave, dielectric, and ohmic heating is the another system. Now, main limitation of that UHT, we required a high processing cost and complexity of the plant. It is very necessary to the sterile packaging material and associated with the pipe work and tank. It need a maintenance of the sterile air and surfaces in filling the machine, and higher skill level required. Process for the autoclave heat sterilization, like air removal, downspill displacement, steam pulsing, vacuum pump, super atmospheric and subatmospheric. Type of the packaging for thermally processed food product, that is your retort pouches, Tetra Pak, glass jars, plastic cans. Retort pouch are the three-layer laminate. That is, first layer is your mylar or polypropylene outside surfaces. Second is your aluminum. It is a barrier to the gases and the water vapor and hermetic container. And third layer is your polypropylene, which come in contact with the food product. Inert means that it can prevent the contact of the food with that aluminum, and they are heat resistance. Heat sterilization effect on a food product. Okay, so purpose of the sterilization is simply means that we have to extend the shelf life with a particular ambient temperature, and also minimizes the changes which occur in a nutritional quality of the food product and the sensory characteristic. But when we compare with pasteurization, there is a higher loss of their sensory and nutritional quality. Okay, like suppose that if we first we talk about the color of the food product. When a time temperature combination of the sterilization affect the pigment of the food product, like in meat, it affected the red oxymyoglobin pigment, which converted into the brown myoglobin when a high temperature is applied. Okay. Now, purplish myoglobin also converted into the red brown myohemomicromogen. Sodium nitrate and botulinum nitrate are added to the meat, which reduces the risk of that Clostridium botulinum, and also maintain the red and pink color of the food product, which is occur either due to the presence of that nitric oxide, myoglobin, and metmyoglobin nitride. If we talk about the fruits and vegetable canning process, then here the chlorophyll is converted into the pheophytin, and iron or tin is react with anthocyanin, which form a pigment. Colorless leucoanthocyanin form a pink anthocyanin complexes, and that sterile milk have a slightly color changes which is occurred due to the reaction that is known as a caramelization, and the another reaction that is your Maillard reaction. Flavor and aroma. If we talk about the canned meat, then it interact with the following component which produces more than 600 flavor, that is your pyrolysis, decarboxylation of that amino acid, Maillard reaction, caramelization of the carbohydrate to furfural, oxidation and decarboxylation of the lipid. And in fruit there is a complex reaction occur which is your degradation, recombination, volatilization of aldehydes, ketones, sugars, amino acids, and the organic acid. In milk, there is a development of the cooked flavor take place, which is occurred due to the denaturation of the whey protein, which form a hydrogen sulfide. Texture or viscosity. Okay, if we talk about the canned meat, then there is a changes occur in their texture, and this changes is occur due to the coagulation and loss of water holding capacity of that protein. It can produces a shrinkage and stiffening of the muscles. There is a softenings are occur, and that softening are occur due to the hydrolysis of that collagen and melting and dispersion of the fat through the product. Polyphosphate are then added into the canned meat, which bind to the water and increase the tenderness of the product, which reduces the shrinkage. If we talk about the fruits and vegetable, then the softening are occur either due to the acting material present into the fruits and vegetable, and they are hydrolyzed. Then a gelatinization of the starch and solubilization of the hemicellulose, but this solubilization is partially. Then calcium salt are added to the blanchard of water of fruits and vegetables, which are insoluble calcium pactate and increase the ferments of the canned product. Then there is a small changes are occur in the viscosity of the milk, and that changes are occur due to the modification of the KKC, and also increase the sensitivity to that calcium precipitation and coagulation. Then their nutritive value, proteins are coagulated in case of the canned meat, and amino acids are 10 to 20% of the amino acid are losses. Then lysine and tryptophan, which are present into the canned meat, are reduced, and some biological values of the proteins are also reduces by around 6 to 9%. Thiamine losses occur around 50 to 75%, and pantothenic acids losses occur during 20 to 35%. If we talk about the canned fruits and vegetables, then there is a significant loss of soluble vitamins and particularly ascorbic acid. Sterile soya meat produced may shown increase in nutritional value, which are occur either due to the decrease in their stability of the trypsin present into the food product, which act as the inhibitors. Okay, and this trypsin is present into the soy beans. So this is all about the sterilization of the product in our food processing. I hope you will understand, but if you have any query related to this, you are freely to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube, and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.